We are introducing PolyX, a Maya plugin authoring tool that can learn and propagate shape placements in 2D scenes based on examples given by the user. Here is a quick and simple overview of what PolyX can achieve. It learns from the 3 examples given on the right and places a new blue polygon that was originally missing from the scene.
Goals and objectives. Modeling can be a tedious task when you have to continuously place the same object in a large scene. Our tool helps reduce that time-consuming task by learning to propagate shape placements in 2D polygonal scenes from a few examples provided by a user. The main capability of our tool is that it takes in a set of example placements as simple 2D polygons and is able to output a new scene with similar placements to those in the input. Our approach is based on the SIGGRAPH paper from 2015 called Learning Shape Placements by Example. The technical approach starts by getting the information from the user, which are the example scenes and the scenes we will propagate with our tool. We then get the bounding boxes for the different elements in the scene. We use the corners and center of those bounding boxes to calculate the relationships between different elements in the scene, such as the distance from each corner to the closest segment in the other polygons. We create feature sets that contain all the relationship information between each element and the rest of the scene. Afterwards, we use that relationship information to calculate possible candidate placements. Based on the relationships between elements in the example scenes, we can start to approximate what might be the desired placements for the output scene. We are able to evaluate those candidate placements using a target function based on Bishop's kernel regression. That function gives us a set of values that indicate the level of similarity between each of the candidate placements and the placement of that same element in the example scenes. Finally, we simply calculate which of the candidate placements return the highest overall value for the similarity measures. The higher the value, the more similarity there is between scenes, so that candidate placement should be the best. Now that we have found the best placement for our object in the scene, we just need to use its bounding box values to model that object into the scene in Maya. The result is a set of scenes with the desired object placed in the best position based on the given examples.
We would like to show a quick demo of how PolyX works with mirror placements based on walls and sinks. So right here I have modeled out some sinks, mirrors, and walls. On the right hand side we have 3 example sinks, and on the very left hand side we have a sink without a mirror. So that's the scene we want to populate. So I open up the PolyX window. We have exactly 3 example sinks. Right now I'm clicking on each object and giving it a name and pressing OK, and making sure everything is in the correct group in this drop-down menu. I'm going to go ahead and label the 2 other groups. In the panel, you can see everything is labeled correctly, and we have one output scene in this case. I'm going to label the object, the wall, and the sink. And what we wish to populate is a mirror. I'm going to enter mirror in this text box, press enter, click propagate. As you can see, the placement of this new mirror is pretty convincing when we make some observations against other objects in the example sinks. The distance from the ceiling are consistent, the width is consistent with the sink's width, and the distance between the mirror and the sinks are also consistent. Save example sinks as a JSON file. Continuing from the last demo, I already have all of the example sinks labeled. So instead of having to label everything again or providing new example sinks over and over, instead we can click on Save JSON and give it a name and save all of the example sinks as a JSON file, which then can be loaded into another scene without any of the examples provided. So we just click on Load JSON, find the desired example scenes you wish to load, click on OK, and go ahead and label the output scene. So in this case, right here, I'm missing a mirror. Once again, I'm going to label the wall and the sink. So I wish to propagate a mirror, so I type in mirror and click on propagate.
In this demo, we wish to place balconies based on wall, window, and door positions in the scene. We have 4 example scenes in the bottom, and I already went ahead and labeled everything. The 3 scenes on top are our output scenes that are missing balconies. I already labeled the first 2, and now I will quickly label the last one. After all windows and walls are labeled, we're typing in balcony as our desired object to place. And now we're ready to hit propagate. Since there are more objects in the scene, it can take a little bit longer than the first demo. And now we can see that balconies are placed in our output scenes. To evaluate our result, we will make a few observations. We see that balconies are all placed below 2 windows overlapping with the bottom of the window, and they're above the doors. The resulting placements are very similar to how balconies were placed in our example scenes.